This is Professor Jimenez, and today we will see practice number 9 of decoders. This topic of decoders is quite interesting because it is how you we will see how you can apply them to micro sequencers, microcontrollers, or instrumentation circuits where they drive LCD displays. So a decoder is defined as a circuit that converts an input code with n lines into another code of m lines, provided that n is less than m. So we will start designing a 2 to 4 line decoder using table 1. In this table you can see that we have 2 inputs, 4 outputs, and the inputs are called A and B. The outputs are called x0, x1, x2, and x3. So when both inputs x0 and x1 are zeros, your output x0 will be 1. When you have 0, 1, your output on x1 will be 1. When you have 1, 0, which is number 2 in binary, x2 will be 1. And for x3, the output will be 1 when we have number 3 in binary code, which is A and B equal to 1. So this is established in these equations because x0 is equal to not A and not B. Then x1 is equal to A and not B. x2 is equal to not A, B, and x3 is equal to A and B. Notice the asterisk represents the AND function, okay? The logical AND function. The resultant circuit from these 4 equations is represented right here, where we have A, this line is A, with an inverter we get not A. We have a line called B and another input line called not B with an inverter. So from here we make our selection using the AND gates, or we can also select NAND gates if we want the opposite function, okay? So we have this function, x0 is equal to not A and B, A not B, x2 not AB, and x3 equal to AB. So, and I represented this way with NAND gates because it is the most common way to represent them or to design them inside a circuit. But of course, many decoders, instead of needing ones here, they represent zeros in this line. So, and by placing another inverter here, you have the true values of x0 through x3. With an AND gate, you will get the not x0, not x1, not x2, not x3. Okay. So another application will be the 3 to 8 decoder, as it is represented right here, with polarity control. So a 3 to 8 decoder is one where 3 inputs are decoded into 8 outputs. In this case, they are called Y0 through Y7. You see, they are, you can see the ones right here. So just to give you a case, the first case is Y0 is equal to not A, not B, not C. And so on, you can get the equations until you reach Y7 equal to A and B and C. Notice that I always place A, B, and C in this order, not the opposite order, to indicate that A is the least significant bit and C is the most significant bit of these inputs. Okay, so from that truth table, you can get the Boolean equations from for Y0 up to Y7, and you have an A, not A, B, not B, C, and not C. So those lines here are ready, so that ready for you to select with 3 input AND gates at the correct Boolean equation that represents each of those. As we said a moment ago, for Y0, not A, not B, and not C, are the ones that correspond. So we select not A, not B, and not C, right here, you see? And this is the AND gate. So now we add the polarity control with the exclusive OR gate to determine if you want the Y0 or you want the not Y0, okay? Also for Y7. So because the polarity control is connected to all of them, this is why you can control the polarity with a single bit called pole, okay? And this is very common in many decoders, but right here we are adding that. The good thing about having the equations is that if you are learning or you are using a PLD, a programmable logic device, in the software you will have to write all the equations. That way you can add the pole, the exclusive OR pole, and you can control the polarity. Okay. For other courses where you see digital logic or microcontrollers, for example, the most common type of the decoder is the BCD to 7 segments. And a classical, there are many types, of course, like the 74 series, 7447, 7448, and in CMOS, the CD4511 or 4547. I prefer the 4543 because its versatility. It's versatile and it can it allows me to control or to control a common anode, common cathode, and LCD displays, well, numerical LCD displays. So this is why I prefer to use this one. So if you are working with another type of display, you just select it with the phase input, the pH input or phase. You don't need to get the correct decoder. So the 4543 is versatile in this type of applications. Okay, so this decoder has, as you can see here, has the 4 inputs, A, B, C, D, where A is the least significant and D is the most significant. LD is a latch disabled, so it has a latch, so you can store the reading, the binary input, you can store it while you are displaying. This is useful because many times you store it because you need to keep the reading for half a second or 1 second on the display. The phase input allows you to select common anode, common cathode, or LCD displays. And the BS blanking input is you can turn off a digit, especially if you are controlling the leading zeros. So you have zeros on the left side of the display, then you don't need them consuming energy. You can blank those digits. BSS is ground, BDD is voltage, which can go from 3 to 15 volts in this technology. But we will work at the standard 5 volts. The 7 outputs are A, B, C, D, E. Notice that F is here and G is here. They are always in that order. Now, the truth table tells you how the inputs are selected. So you have a code 0 here. This code will be represented in the display like this. But if you have input number 1, that'll be the 7 segments represented in 1, number 2, number 3, and so on until you reach number 7, which will be decoded with all these outputs. Notice how all the combinations form the 7 segments display. If you have a number greater than 9, like such as 10 through 15, the display will be blank. Okay, and also if blanking input is 1, the display will be blank. So when we have LCD displays like this one, you can see that these displays have a mark right here, so that's indicates pin number 1 is here through pin number 12, pin number 13 is here, and 24 is there. So you have to count them this way, 1 through 12, 13, 14, until you reach 24. This mark or notch, you can see it there, you can see it there. That's always has to be on your left side when you are driving these displays. Okay, the standard brand that I've been using for a long time is Lumix, and this is the serial number. And of course, you can get them from different suppliers. The schematic, the electronic schematic, we can see that the common pin the backplane, sometimes they call it backplane or common, is pin 1. And for example, the least significant digit, or LSD, its connections are here: A, B, C, D, E, F, and G for this LSD. For the middle one are the green ones, and for the most significant digit, or MSD, this digit on the left they are here: A, B, C, D, E, F, G. Okay, so those are this is the pin out or pin configuration. Okay, now